All right, in this video, we're going to discuss conditional probability. Hopefully you've been following along and watching the other videos on probability. If not, go back and watch them. Okay, so conditional probability deals with saying something like the probability of A given B. Okay, so what's the probability? You already know that B has happened. What's the probability that A happened? Or in my blue shirt and stand if you're wearing a blue shirt or stand if you're a girl. This is saying what's the probability that they're wearing a blue shirt given that they're a girl. Okay, so then that changes kind of the world that we live in. We'll get there. I'll explain a little bit better as we go. So keep in mind with this one, this part right here in our Venn diagram is the this is the intersection. So A intersect B is that right there. And so if we're saying find the probability of A given B, it's easy to see it in a Venn diagram. That's saying, okay, you're living in the world of B, whatever this world is. And so what's the probability in this world that you're also in A? So what we're going to do is we're going to define this to be the probability of the intersection divided by the probability of B. Okay, so we're living in this world now. That's our denominator, and we were concerned about the spot that's also in A. Looking at a tree diagram with this, what we have here, let's label the different parts of the tree diagram. We haven't quite done that in a video yet. So just without using numbers. So this becomes the probability of A. Whatever the probability of event A happening is what we'd write here. And this is the probability of not A. Okay, so then this branch right here is the probability. It's not just the probability of B, it's the probability of B assuming that A already happened. So this little branch, what we write down is the probability of B given A. Okay, so what that's saying here is we already know A happened. We've gone down this branch, and now what's the probability that B happens given that A has already happened? This becomes the probability of B not given that A has already happened. Okay, the probability of B not given A. We're already down this this branch of the tree. Over here, we end up with the probability of B given A not. Okay, we already know A naught has happened, and now we want to know what's the probability of B. On this one, the probability of B naught, this one is the probability of B naught given A naught. Okay, so now do you remember as we were working some of these tree diagrams, we would write out the probabilities off to the side here? Well, this one right here is the probability of A intersect B. Okay, and this one coming this way, this is, well, we had A intersecting with B naught. So this is the probability of A intersecting B naught. Over here, we have the probability of A naught intersecting B. And this is the probability of A naught intersecting B naught. Okay, so if we think about our Venn diagram, kind of mixing these two, mixing the tree diagram and the Venn diagram, probably A intersect B is this part that I already colored green. A intersects B naught. Well, outside of B is all of B naught intersecting with A, so that's this little crescent shape right here. This one, A naught intersecting B, is the other crescent shape. It's outside of A and then intersecting with B. This one, probability of A naught intersecting B naught, is the outside part. It's not inside either one of them. So you can see the connection between the two. So if I want to find the probability of A given B, what I need to do is I need to find, well, we said that we're changing the world we live in, and so we want to divide this by the probability of B. But how did we get the probability of B? Well, we get B from this place here and this one here. Okay, the theory is more in line for HL than SL, but I think it's interesting to know the HL might be expected to know more of the theory. SL, you just have to work problems. That's been my experience in the past. So on this one, we're saying, what's the probability of A given B? Well, we got B here and here. And so that's the probability of B, and we want to know what's the probability of A intersecting B. So it's this. Okay, and then when we go a little farther, well, what we're going to say is it's these two things added together that give you that. So the probability of A given B is equal to the intersection divided by these two things added together, the probability of the A intersecting with B, plus the probability of A intersecting with not B. Okay, really and truly, SL, you just have to work problems. And HL, we're going to talk more about this theory as we get into Bayes' theorem. Okay, so let's see. I think I want to do this example next. So if you remember, I talked in a previous video about my car doors not opening, and that was so fun. I now have a new to me car. It wasn't brand new, but I'm loving it. And but before that, the doors didn't open. Or they wouldn't. Who knew? Okay, so what we're going to do is we're going to say we solved this problem before, and when we found these probabilities out here, we're saying find the probability that my passenger sits in the front seat. Okay, so that means that I have a passenger. Okay, so what that means is I can't have had both doors not open. Okay, so I could have had any of these three scenarios here, but I want to know what's the probability that they sit in the front seat. Well, maybe I should say, what's the probability that my passenger, well, let me tweak this a tiny bit. Okay, well, in the front seat, I don't know if they're sitting here. I mean, that could be either one of these. They have the option of sitting in the front seat, so I didn't think through this one as clearly as I probably should have. And they tend to write these questions a little better than I did. But because I don't know, they have the option of both at this point. So let's say, let's tweak this a tiny bit. Let's say that knowing, what's the probability that I was able to have a passenger knowing that the back door didn't open? Okay, so basically what I'm trying to do is find the probability of having a passenger in the front seat knowing that the back door didn't work. So what I want to do is I want to find the intersection, F intersecting with B naught, over the probability, oh, I don't know why, probability is a P, my goodness. Oh, there's that F, that's what my brain's doing. No, I want B naught right here, B naught. Okay, let's try that again. It's the intersection divided by this one here, yes, okay, I've matched my formula. So the probability of F intersecting with B naught is this 0.12. The probability of B naught, well, B naught were these two together. So I have a 28 plus 12%, so I have a 40%, 0.4% chance of the back door not opening. And so where were we? This we could clean up. Well, 4 goes in there, 3, 4 goes in there, 10. So we've got a 30% chance, 3 out of 10 chance that that I can have a passenger, assuming that the back seat doesn't open. They'll come up with better problems for you to practice. Sorry about that. Let's look at this one really fast. They tell us that the probability of A is 0.6. The probability of A union B is 0.8. The probability of A given B is 0.6. Probability, and then when they want us to find this. Okay, so on this one, I think I want to draw a Venn diagram. Okay, so if this is A and this is B, the probability of A union B is 0.8, which means that everything in here is going to add up to 0.8, which means that things out here is 0.2. Okay, so then they tell us, does that make sense where we got that? The stuff that's in the universal set that's not in A union B is going to be 1 minus that, which is 0.2. Now they're telling us that A itself is 0.6, so everything in here is 0.6. So that means that everything outside of it has to be 0.4. Well, we already have accounted for 0.2, so this is also 0.2. Okay, so now we know that the probability of A given B, the probability of A given B, well, let's call this little piece right here X. And what we can do is this, well, we know the probability of A given B is equal to the probability of their intersection divided by the probability of B. A given B, yes. Okay, so what we know, this right here is going to be, well, the probability of A given B is 0.6. The probability of A intersect B, well, we just put an x there. The probability of B is this entire circle, which would be this x plus the 0.2. Okay, so now I end up with 0.6x plus 0.12 is equal to x. If I subtract that, I get 0.4x, 1 minus 6/10. Divide by 0.4. Oh, that's fun. Let's multiply by 10 or 100. So this is 12 over 40 is equal to x. We can reduce that by divided by 4. That's 3 over 10. Oh, funny. So x is 3/10 or 0.3. That's this right here. Now we have to go back and see what was the question they asked. Is this our answer? No, because this is the intersection. And so I want this whole thing, so it's 0.3 plus 0.2. The probability of B is equal to 0.5.